This is the 7.5 part 1 video answer key. I'm going to go over a few problems from the homework. And again, if you have any other questions outside of these, you can ask me. This is just giving you a place to kind of start and help go over some of the things that might not be as easy to pick up in the written answer key. 7, 8, 9, and 10 all are very similar, but I'm going to go ahead and do number 9 since we haven't done anything with tangent in the notes. But again, I've got A, B, C, and D there. And I see that I'm looking at the sine of 2 theta, cosine 2 theta, sine of theta over 2, cosine of theta over 2. I know that for all of these, I'm going to need to know the sine and cosine value, and all I'm given is tangent here. What I'm given is that my tangent of theta is 4 over 3, and then I know that it falls between pi and 3 pi over 2. What this actually means, though, is that it's a quadrant 3 angle, and since it's a quadrant 3 angle, that means that I'm actually looking at a negative adjacent and opposite side. So tangent is opposite over adjacent, so this means I'm looking at an opposite of -4 and adjacent of -3. Again, the book is doing a really good job of setting this up for us. They like giving us these 3, 4, 5 triangles. So then I've got a 5 for my hypotenuse value. That means that my sine of theta is equal to -4/5, and my cosine of theta is equal to -3/5. And I'm going to go ahead and I'm going to stop and start thinking about what I'm being asked at this point. So the first thing that I'm being asked is to find the sine of 2 times theta. So I consider what my sine of 2 times theta is. Well, that's equal to 2 times the sine of theta, which is -4/5, times the cosine of theta, which is -3/5. This multiplies out. This is equal to 2 times, this is equal to 2 times positive 12 over 25, which is equal to 24 over 25. And again, I'm going to stop and think really quick. If this falls between pi and 3 pi over 2, 2 times this means that this falls somewhere between 2 pi and 6 pi over 2, which is 3 pi. So this is falling somewhere between quadrant 1 and quadrant 2, and in both quadrant 1 and quadrant 2, sine is always positive. So that makes sense to me that it's falling in between one of those 2 quadrants, and I've got this positive sine value. Next thing that I have is to find the cosine of 2 theta. I can use any of the formulas I like. Since I have the sine and cosine, I'm going to have a little bit of fun with this one, and I'm going to go ahead and do the cosine squared of theta minus the sine squared of theta. And I'm going to say to myself, okay, that means that I am looking at -3 over 5 squared minus -4 over 5 squared. And that means I'm looking at 9 over 25 minus 16 over 25, which is -7/25. And this means that I'm probably looking, well, I'm not probably, I'm definitely looking at an angle in quadrant 2 now. I've got a positive sine and negative cosine. And with this double angle formula here, the fact that it falls somewhere between that 2 pi and 3 pi over 2, I know that it totally could fall in quadrant 2 where my cosine's negative and my sine's positive. So that works out for me. I'm happy with that. Part C is now asking for the sine of theta over 2. Sine of theta over 2. And here I have to start thinking about where this falls. I know that it falls between, I'm going to kind of convert this into numbers to help. This angle's falling between 180 and 270 degrees, so that means I'm going to divide it by 2. And again, this means that it falls between 90 and 135 degrees, which means that this is a quadrant 2 angle, which means that this sine is going to end up being a positive value of sine. So I'm going to go ahead and plug this in. This will be the positive square root of 1 minus the cosine of alpha. So this becomes 1 minus -3 over 5. I keep that -3 over 5, and I keep it as a negative no matter what. And this is all over 2. So this is the square root of 1 plus 3 over 5 over 2. This is the square root of 5 plus 3 over 5 over 2, square root of 8 over 5 over 2, square root of 8 over 5 times 1/2, square root of 8 over 10, 2 times the square root of 2 over the square root of 10, multiply by the square root of 10 over the square root of 10, 2 times the square root of 20 over 10. That will reduce square root of 20 over 5. The square root of 20 breaks down into 2 times the square root of 5 over 5. So that's what the cosine, or that's what the sine of half of that angle would end up being when we plug it into the formula, and it's going to end up being positive because I know that this is going to be a quadrant 2 angle. My cosine, however, since it is a quadrant 2 angle, it still falls between that 90 and 135 degrees. That means my cosine of theta over 2 is equal to the negative square root of 1 plus this negative 3 over 5 all over 2. So this is the negative square root of 5 minus 3 over 5 over 2, square root of 2 over 5 times 1 over 2. Those will reduce. This is the square root of 1 over 5. This becomes the square root of 1 over 5, rationalize, or square root of 1 over the square root of 5, rationalized by multiplying by the square root of 5 over the square root of 5. And we end up with the square root of 5 over 5. And then it's negative because, again, we're in quadrant 2. So then your cosine of this is, cosine of theta over 2 is negative root 5 over 5. If you want to break it down and think about it, when I'm looking at the sine and this cosine, they both have the same hypotenuse value. And if you go through and actually do the Pythagorean theorem on that 2 times the square root of 5 squared plus the square root of 5 squared, it will be equal to, it will end up being equal to 25 because you'll have that 5 squared. So this actually is going to end up going through and working with the Pythagorean theorem. In fact, I'm just going to go ahead and prove it because this is a good way to check yourself. So this is the square root of 5 squared plus 2 times the square root of 5 squared is equal to 5 squared. So this is 5 plus 2 squared times the square root of 5 squared is equal to 5. So that's 5 plus 4 times 5 is equal to 25. 5 plus 20 is equal to 25, and 25 is equal to 25. So that checks out. So I actually went through, I checked what my opposite versus my adjacent side, because cosine of theta over 2 should still be the same theta. It works out. Those angles and sides make sense to me. So I'm really happy with that I have this angle that really seems to work out and even goes with the checked work there. So I call that good. And 7 through 10 are all like that. 19 through 28, this is where you actually kind of have to go through and know what angles you're talking about here. So for example, I've got on number 19, we're talking about the sine of 22.5. Now this one's really straightforward in the sense that you know that this is in quadrant 1. 22.5, this is the same thing as the sine of 45 degrees over 2. So I'm going to go ahead and plug this into that formula. 1 minus the cosine of 45 is root 2 over 2, and this is all over 2. So this becomes the square root of 2 minus the square root of 2 all over 2 over 2. Square root of 2 minus the square root of 2 over 2 times 1/2. Square root of 2 minus square root of 2 over 4, and that simplifies down to the square root of 2 minus root 2 all over 2. My denominator's rationalized. I can't simplify that numerator anymore. We leave it as is. Some of the more complicated ones here. when you start doing this, I'm going to go ahead and jump to number 26 actually, because this is going to help you with a lot of these. When you're doing this with the radians, you have these fractions. So what you have to remember here is for 26, when I've got the cosecant of 7 pi over 8, well, if I'm doing alpha over 2 here, what I have to remember is that I'm multiplying it by 1/2. So this is actually the same thing as the cosecant of 7 pi over 4 over 2, because the 7 pi over 4 divided by 2, we're going to go ahead, we're going to say 7 pi over 4 times 1/2. Well, that's equal to that 7 pi over 8. So that makes it a little bit more difficult because we're not dealing with the numerator as well. We're only really changing the denominator when we end up dividing by this 2. So we have to pay attention to the fact that only the denominator is changing. Now that I'm here, I'm going to write this as 1 over the sine of 7 pi over 4 over 2. So then that means I'm looking at 1 over the square root of 1, and in this case the cosine of 7 pi over 4 is positive, so this is minus root 2 over 2 all over 2. We've done the simplification of 1 minus the square root of 2 over 2 over 2. We did that up there. We realize that this is 1 all over the square root of 2 minus the square root of 2 all over 2. And when we flip that around, we get 2 over the square root of 2 minus the square root of 2. Now I'm actually going to leave this here. I'm not going to simplify this further. This isn't the easiest thing to rationalize, especially when I have that square root inside that square root. So I'm going to call this good here. I'm going to leave it as this. It's the most exact answer. Sure, it's not rationalized. Sure, it's not fitting the simplification rules that we like, but I'm going to call it good here and say that this is my answer there. I'll actually jump back and also do number 25 for you guys. We're looking here. We've got the secant of 15 pi over 8. Well, again, when we think about this division by 2, we're talking about the secant here of 15 pi over 4 over 2, because again, when I do this, 15 pi over 4 over 2 is equal to 15 pi over 4 times 1/2, which is equal to that 15 pi over 8. So this is actually the cosine of 1, or cosine of 15 pi over 4. 15 pi over 4 actually ends up, when you draw this angle out, you can stop and think about it. This is 8 pi over 4. This is 12 pi over 4. 15 pi over 4 is actually going to end up in the same position as 7 pi over 4. So this is going to end up giving you a, this is going to end up being in quadrant 4 here for that 15 pi over 4. So I do 1 over the square root of 1 plus root 2 over 2 all over 2. This is going to be 1 over the square root of 2 plus the square root of 2 over 2 over 2. This is all going to simplify. I'm going to jump the simplification here. You really should start seeing this pattern of the over 2. So I end up with the square root of 2 plus square root of 2 all over 2. And then I end up with 2 over the square root of 2 plus the square root of 2 to finish it off there. One thing that I'm going to go back and do on number 26 as well, for 25, I have to consider my original angle. 15 pi over 8. 16 pi over 8 would be equal to 2 pi. So this is actually a quadrant 4 angle here. And since this is a quadrant 4 angle, this angle is a quadrant 4 angle. Since that's a quadrant 4 angle, that means my secant is positive, so this checks out. I'm going to leave my answer here as this 2 over the square root of 2 plus the square root of 2. Up here, I didn't do this at the beginning, so for number 26, let's think about that. 7 pi over 8. Well, 7 pi over 8, 8 pi over 8 would be pi. So that means the 7 pi over 8 is a quadrant 2 angle, and this actually works out for us because that means that our cosecant is going to be a positive, so we end up with that positive 2 over the square root of 2 minus the square root of 2. So that actually worked out, even though I didn't do that from the beginning, but you do need to make sure you're paying attention to the quadrant those original angles are falling in. A little bit easier when we have the angle, we can go through and figure that out. A little bit harder on the example from the notes. And the first example from number 7, where I actually have to stop and think about, okay, divide out the angles and figure out which quadrant it ends up in. So that's the video answer key. You have the written answer key as well. If you have any questions or concerns, please reach out sooner rather than later, and have a great night.